Welcome.
To the joy of coding.
Hello, and welcome to episode 97 of The Joy of Coding. My name's Mike Conley. It's going to be a hacking on Firefox kind of day today. Yep, that's how we're going to be rolling. We're going to be working on some Firefox stuff. I'm going to be trying again to make tab close faster. We tried this last week. We didn't get too far. We got like a little bit of a roadmap put down. We got some stuff written, but I don't think any of it was landable at all. But this week we're going to keep trying to push through and do our best and see where we got. But before we go into that, let's take a look at the agenda. Let's see what's going on for today. So let me share my screen. One sec. Here we go. Today is April 12th, 2017. A reminder that no plan survives breakfast. I'm going to do my best to stick kind of to this general set of things that I want to do, but I might get off the rails. I might not make through it all. I might screw up. It happens all the time. I might get distracted. Who knows? Someone might drop something into my lap that I have to deal with. And so just be advised. Might have things go wrong. So no plan survives breakfast, and that's okay. So a quick self-check. Is everything working? Yes, you can hear me. Can you hear the sounds? Yes, you can. I am recording. Excellent. I have alternative stream links for you in this agenda, which, if you're watching this live on AirMozilla, YouTube, Facebook, or Twitch, you might want to, if you're on AirMozilla, scroll down to the additional links section, because there's a link to this agenda, which you can open and then click on these links. If you're watching this on YouTube, it's in the video description. If you're watching this on Facebook, it's below the video. I commented with the agenda link. And if you are on Twitch, I'm just about to drop the link in the Twitch chat. Bam! Done. So it's in the Twitch chat. There's also a thing going on. So alternative stream links. All those different types of streaming services, you can get links to each one of these. I post to this subreddit called Watch People Code, and that is right here. And I have the stream links along with the agenda and a link for rating the episode here in the Watch People Code subreddit. So I do encourage you, if you're not currently comfortable with the video service that you're using, try an alternative. I'm streaming to a bunch of different services now, so give them a shot. So I want to also point out that there's going to be no episode on April 26th. That's the week after next, I believe, if I've done my math correctly. We'll be skipping that episode, so episode 99 is going to be delayed. And then after that is episode 100, and we're doing something special for the 100th episode to celebrate 100 episodes of The Joy of Coding, roughly 100 episodes. I'm taking a survey on what bugs from Bugzilla you want me to fix. I've identified a couple of bugs that have a high number of votes. Take a look at the survey. Go ahead and vote. And we'll see what happens. I'm not promising that I'll be able to fix the bugs. I'll just attempt to, and I might not fix it the way you want me to fix it to exactly, but I'm going to try and somehow drive the bug to a resolution, or at least provide some kind of alternative or something based on whatever bug is selected. So do fill out the survey. I'll reveal the selection probably at the end of the 99th episode. So that's in I think the beginning of March, beginning of May. Last month was March. I need to get my my calendar sorted out in my head. I also want to give out a call to action. If you are interested in helping to make Firefox faster, this is something you may have seen me do before in the past. You may have heard me talk about these things, but there's a tool that we have called the Gecko Profiler. It helps us to find out what Firefox is doing whenever it's being slow, so we can stop doing those slow things. You can get a copy of the profiler if you go to perf-html.io here. And install the Profiler add-on if you're using Nightly. I think that's the version that we want you to use. And then there are instructions, a performance problem. There are instructions right here on how you can report a performance profile, or report a problem. Grr. gather a profile. Hang on, let me put this link in here. Gather a profile. And then, hop. So that's another link in there. This is all quite sloppy. And then this last link is actually to a spreadsheet I've put together that will allow you to send me your profiles so that you can submit them for analysis. You can tell me whether or not you want me to talk about it publicly. I'm going to try actually to spin up a separate show just for profile analysis. It probably won't be nearly as long as The Joy of Coding. It might be a little half-hour show every week where I and some other Firefox engineers are going to be looking at the profiles you send in, assuming you give us your approval to talk about the profile publicly. So do fill in this form. I want your performance profiles, and we'll go through them. So what do I want to do today? Well, yeah, I talked about making tabs close faster. Before I do that, though, there was this other patch that I tried to land yesterday, and it bounced due to a test failure. I want to try again to land that. But in order to do that, I need to figure out how to run a certain type of test. So let's see here. This is what I wanted to land. There's this thing called this bug. I'm getting rid of some old terminology in the tree. This one here. I'm going to rebase that onto current tip so that I don't have to do a load of rebuilding, which would slow us down. So I'm just going to throw it onto tip here, and then I'm going to basically there was a test failure because I failed to fix a test. I removed a reference to a thing, and I didn't get rid of a test that referred to that thing. So I got rid of these two uses of SPS profile. We're switching it to gecko profile, and I forgot to fix this one here in a test. So what I'd like to do, and there are a couple of references to it in here, but these ones are okay because these ones are deprecated, and so we're still accepting SPS profile, but it's deprecated. But here I want to stop using it. So I have to not only fix this test, but then run the tests to make sure that I haven't done anything wrong. So let's update to tip, and then what I'm going to do is I'm going to try and figure out how to run these tests. How do you run these tests? Like, what are these tests? This is test try option syntax. It's a unit test. So it's like just a standard Python unit test. So I wonder if I can just do like nose. If I can just use nose test. It'd be great if there was like some kind of documentation here. All right. So this is in the task cluster task graph directory. Is there any kind of like virtual env thing, or what if I just do nose test? No nose. Pip install nose. I think I need to do that. I think these are nose tests. I should double check. It's been a while since I've written tests like this in Python. Unit test test case, and that's coming from where? This this Python unit test module. Let's quickly figure out what this is, how it works. Sometimes it's PyUnit. It's not nose, it's PyUnit. And how do I use PyUnit? Unit test main. So there's something that's going to call unit test main. Oh, so if I just run this Python script. Okay, that's fair. I can do that. Don't need to install nose. I just need to run test try option syntax. In non-package. So I have to do it where? Here in task graph, Python test try option syntax. Oh, test try option syntax. Hopefully you can read what I'm writing. Let me pump up the font a little bit actually. Whoopsie daisy. There you go. Test try option syntax. Do I have to go one deeper? Task graph. Attempted relative import in non-package. How do I run the task cluster? Oh, there are mock commands. Oh, that's good. Run the task graph unit test. That's exactly what I want. Okay, good. Mock task graph. So there, mock task graph help. Tasks. And what there was Python tests. Yeah, that's what I want. Mock task graph Python tests. Hey, and they all passed. I think they all passed. Did they? Oh, nope. This one failed. This is the one that failed because we expected it to fail. And now I'm just going to fix it so that it passes, and then we're done. And then we can commit it to the tree. I don't think I'll need re-review. I already got R+ from Dustin, and so I don't believe he'll want me to bother him about this. Okay, gecko profile, that looks good. Rerun the tests. Looks good, all pass. So let's commit, amend, and push to review, and then auto land. And then we will move on to our making tab closing faster bug. Oh, whoops. I need to reopen the bug, of course. So that's this one. I have to reopen the review request because when you auto land, it closes the review request as submitted, but then we don't reopen it when we back it. You have to do that manually, which is a bit of a pain. Okay, so now I've reopened it.
Mamma mia!
All right. Okay, let's see here. Show the changes. The changes shouldn't be too intense. Yep, just changing SPS profile to gecko profile. Publish. What we're looking at is the interdiff. So that's what changed between the last version and this version. This is the total diff, where I'm changing this from SPS profile to gecko profile, and I'm changing this one here, and changing one in here. And now I am going to land. A boop. Done. Okay, so that's landed on integration. I'm going to set a tag. There, that's how I manage state for myself. And now, let's go on to our permit unload bug. So if you are not familiar with what we're doing, I highly recommend maybe you stop watching this video and go back to the previous one, episode 96, because I explained exactly what we're trying to do. I don't want to waste too much time by explaining what we're doing again, but the overall plan has not changed really. I'm going to try and do it the same way. It's just I've decided to change the order a little bit, because before I was like I think I wasted a bunch of time trying to add some assertions when, like, let's just get to the meat of the problem. We'll add some assertions later. So I'm going to, now that that's done, I'm going to go back to the previous patch, and this is what we're going to work off of. We can take a look at where we are at so far. It's a lot of just sort of, what's the word I'm looking for? Speculative code. I need to know more about how it works, how, like, window closing works and stuff, but, like, this is where the patch is so far, where in the global window, when we are freeing inner objects, which I presume means we're shutting down the window, then we are getting rid of, we're finding the tab child from here, and then we say before unload, and then tab child, then before unload. Yeah, so this is, if we're closing a window, we want to tell the parent, hey, all those before unload listeners you were tracking for me, don't track them anymore. So decrement those if I've gone away. And I've also added this thing so that we track whenever a before unload event is added, and if we are a window that will respond to a before unload event and we're in a content process, then we tell the tab child, hey, track this. And if it's removed from via remove event listener, then we say, okay, remove it. And then we do need this function here to get a count of how many exists, so that whenever we close a window, we can quickly scan uh, um, the list to see, okay, well, how many are there that we don't need to worry about anymore. I'm not sure if this is preferable to, say, having an internal count that is incremented and decremented on the event listener manager at these points, but we can deal with that later. And then I've got these little stubbed out before unload added, before unload removed functions on the tab child. That's what we really, really want. And that's it. That's all that's going on. And there's a problem, and I'll try and demonstrate the problem. The problem, oh, it's a cat. The problem is that, let's see. I have this before unload event being added whenever I run this JS. So there, one was added. And then when I close, say I close the tab, it's not getting cleared when I close the tab, which I don't know why. So that's what I want to figure out. Are we not freeing the right inner objects? What is going on? So first thing, I'm gonna clean up my workspace just a little bit, just to I know there's some people who are really sort of picky about having a clean workspace. I am sometimes in the same boat. We're gonna try and just let's clear this up, make it a little easier to reason and see what's happening. So the first thing I want to do, so let's write down the question. Why is the counter not being decremented when the subframe is destroyed? So maybe our assumption is wrong, and free inner objects isn't being called for every window. But let's find out. So free inner objects called for, and then I'm going to give that $P is how I can print a memory address. We're going to print our self, and then I'm going to say found before unload listeners for this, and then here I'm going to say found no tab child for that, and then else I'm going to say found no listener manager, because any one of those conditions could result in us not doing what I think we're supposed to be doing, because we don't return early. So if it's possible that we're just not entering for the subframe, or we are entering but we're just not getting to this point because of one of these conditions is not being met. So let's find out. We're going to close the tab, close the browser, build binaries. Hopefully this doesn't take too long. Sometimes waiting for builds is what you gotta do. Come on, I'm playing. There we go.
Oh.
When I play a sound, I like it to play immediately, except whenever my computer is thinking about linking. Alright. Alright. So let's run this again. Let's see what our logging tells us. Let's go back to that before unload page. Okay. So let's run. For some reason we freed some inner objects. I don't know why, but you know what we really should do is we should shoot. Let me let me add another logging message, and that's where we add global window. Before unload. Current inner. Get inner window for target. That's what we want. Let's say printf. Whoops, printf. Adding before unload listener for global P, and then doing that. And Barrett is weighing in. What is up, Barrett? You only put this on the printf, not the actual count. Good call. Good call. Yep, that's a good call. Before unload listeners. How come that compiled, I wonder? That shouldn't have compiled. Weird. Good call. Thank you, Barrett. And I also want to do the same thing for... No, you know what? That's exactly where I wanted to do it. I didn't want to do it anywhere else. So we're going to do it there. Let's link. Let's build and link. Thank you very much, Barrett. Would have thought it would have complained about that. Oh, now it's complaining because I forgot to, I didn't put a semicolon in. All right, 325. Classic C. Doesn't like missing semicolons. Let's try that again. Ruin your day. Missing semicolon to ruin your day. Oh, it was my compiler warnings. Yeah, I probably. Oh yeah, there it is. There it is. Good call. So it compiled. It just warned me about it. Good call, Barrett. See, I like this. It's like I have you all kind of along with me, and you can help spot my bugs. I really like that. Help saves me time, actually. It's really good. Okay. Adding a before unload listener for 125 EFA 230. I think that's the right memory address for the thing that we're caring about. And now if I close this tab. Oh, it didn't even like prompt me. What the heck? Oh, you know what? So here's the thing. One of the other things that we have is that we want to make sure that we have interacted with the window. That was a rule that we added. You have to interact with the window for us to consider doing the permit unload. So for 120 D85F70, so I'm going to say, yeah, let's close the window. And we're freeing inner objects. So I don't see DF70 in this list. I got a feeling I reported the wrong memory address. Free inner objects called. So in Event Listener Manager, do we ever make reference to an NS Global? Global. Script Global Object. Maybe that's what we wanted. The script global. So let's try that next, and failing that, I'm going to attach my debugger, and we'll have to do it sort of by inspection. So, oh, it's because shoot. I put in this again instead of window. That's what I should have put. I'm also going to do the global thing. Global. And then you want to have a dock as well. This is all such a mess. Okay, so this is just like a little experimental thing, these two things. Don't worry about them. For global, and then I'm going to say that, and then I'm say window. These might be equal. The inner window and the global might be the same thing. Let's see. Global, and then window. And that's it. So let's build that. Let's see if that helps. What? What? Non-trivial object. Oh, because it is not a pointer exactly. I have to do global.get because it's an ascom pointer. It's almost like a pointer, but not quite. Okay. Buildings. All right, so let's do this thing. Before unload. Okay, so let's run the script. Or let's add some spaces here. So we're gonna run the JS. Okay. So we added it for. They're not the same thing. The global and the inner window are not the same thing exactly. They're close though. They're off by a couple of quite a few slots, but that's interesting. And now I'm going to close the tab. Okay. So then what happened was free inner objects called for all of these are at like 0, 0 free inner objects. And on this one, there was 0 before unload event handlers found for this thing. Free inner objects called for that, ECOO, 020. Interesting. So it doesn't look like I call free inner objects on the thing I care about. Huh. Notify DOM window destroyed. So once again, it's possible that I'm just looking at the wrong thing. DOM window destroyed. Do I need the... I should have also added the outer window to the list. Free inner objects. We assert that we are an inner window. So it should be the inner window. The inner window for the target. So it should be that. I expected it to have been this 1269DFO20. That's pretty close. Not quite. I wonder if... And then after this one, it says that it couldn't find a tab child for it. When destroying it. There's an interesting situation where like there's no event listener manager for some of these things. Maybe it's because on certain subframes no event listeners were added. Because I have a feeling we only instantiate an event listener manager when events are added. And so for one, we saw that an event listener had been added. We did have a manager, so we got in here, but we weren't able to get the tab child from this. And this is a global window. And maybe we're querying tab child wrong. Tab child CPP from. Let's see usages of tab child from. Maybe there's some better examples around the tree that'll be more illustrative. What? No one uses tab child from? Get from, that's what it is. Am I just, yeah, it's get from, I'm sorry. Tab child get from. You can pass it a pres shell, a layers ID, a doc shell, a DOM window proxy. So here's where it's passed to, a window is passed. Here a doc shell is passed. Here you pass an outer window. Maybe you have to pass it an outer window and not the inner window. That would make sense. Get from a window. DOM window, get from window actor. Moses are window, not window, or the window is the inner window. So let's try doing it. Let's just try an experiment. Let's get the doc shell off of the window instead. Yeah, that's around. Get from, get doc shell. Let's see if that helps. I'm guessing a little bit, but sometimes that's how software is made, especially complex software. Sometimes that's how mysteries are solved, by like trial and error. And I know that might be a little disheartening for some of you, and some of you might just flat out disagree, but sometimes you just try a thing, work a little bit on instinct here. But I got a good feeling about this one. If we can get at the doc shell, like I feel like the confusion of inner and outer windows is not helping my case, but I do feel more confident talking about, believe it or not, talking about doc shells and referring to them. Okay, so run the JS. We added a before unload. Let's leave the page. Found 0 before unload event listeners for this 120698000. But we added it here. So here's the problem as I see it. We have an event listener manager associated with the window. We add a before unload event to it. We start shutting down the window. We start shutting down all of these inner windows. And for some reason, we're not seeing that inner window get destroyed. Although maybe we are. It's hard to tell. 12069. No, that's not even close again. And I don't even know if it should have been. This is closer, E8COO. Found no tab child for it from looking at the dock shell. Okay, well, it's debugger time, I think. Let's quickly, let's see, permit, unload, can close, content viewer. We say the content viewer, dock shell. Ask the window if it can close here by asking for the content viewer, the global window. Then we have close outer. Force close, final close, really close. Oh boy. Ask the content viewer where the top level window can close. If the content viewer returns false, it is responsible for calling close as soon as possible for the window to close. Okay. Ask the content viewer, can we close? Huh. We have a global, get global JS object. We also have these like remove event listener here and add event listener probably somewhere else on the global window. I wonder if it makes more sense instead of, like, are we being called here? I suspect we are. I wonder if it makes more sense instead of putting this thing inside here, if we check earlier. I'm going to try a thing. Get rid of this. We're done with that. We're going to go into global window. And we're going to say if type. Now how do we add event listener type? Type string. Event type equals, no. Type atom equals a type atom. Type atom comes in there. How do we turn it into a type atom? We do get event message and atom for listener. So we can turn a string into an atom and do an easier comparison. String, and then we get the out. We'll get an event message. Oh, there's like nested Or there's ternary here. Hold on a second. If there's this, then do that. The messages is main thread, event listener manager, or if true, do that. Otherwise, do that. Get event message and Atom. If you pass in a string, get event message. I want like the Atom for better comparison. Get event Atom? How do I convert an atomize? NS atomize. Event. Event target. Here we go. NSI atom. Set event handler. So maybe I could do. I don't even know if this is the right way to do it, but let's try this. Like atomize the type, and then if the type equals, and what were we doing before? We were doing this. Oh, that's the event message. That's what we want. The A event message, not the type atom. Silly. All right, so we did want get event message and where was I? It was listener. I swear, we were just looking at this. It was like a thing that was like event message. Yeah, get event message and Atom for listener. Has content utils. Actually, what might be better is to look at the header. That might help. Get event message and Atom. Returns the event message and Atom used for event listener registration. Yeah, let's use that. String name and then out. Okay. Whoop. So I'm just gonna whoop. And do that. You know what? I don't care about the spacing just yet. So if the message equals, and then what were we doing before? It was this silly thing. It was like if the event message was before E before unload. And I think I have access to that, e before unload. Do I have to give it some kind of prefix? An event message list. Do I have that in global window? Event message list. I do not. Shoot. What's the other way before unload? In our C++ code. Is there like NSK? Yeah, okay. I can get use the atom. Handler. Event name. Event name. It's an atom. Okay, so we'll use the atom. If atom equals SGK atoms, whoops, lower k atoms on before unload, then we'll do this hacky thing. We're gonna say get child from self. And then adding before unload listener for global. And then I'm going to say myself. So I'm going to say this. And so we'll do that here. And then we're going to do the same thing but removal. Or we're going to do the same thing for the other add event listener. I'm just going to copy it. We'll probably have a utility function, but let's do that here. Adding before listener at 1, just so I can understand it, at 2, and then remove event listener. Will probably work the same way. Just copy this chunk. We're just going to copy this hunk around. Okay, it's just got this one hunk here. Get the atom. If before unload, we get the tab child, and then before unload, removing before unload listener for global such and such. Okay. And then we're going to get rid of that again, and then there was this other thing that we're going to get rid of down here. Hopefully this doesn't require a huge chunk of rebuilding. I hope not. Let's see if it likes it. So let's shut this down. Hello, folks on the Twitch chat. I just realized you're watching and you're chatting. Hi. Hey, and we're linking. Unbelievably, that stuff's gonna compile. Hi-oh. Where's a good sound for that? I got a good sound for hi-oh.
Hi-oh!
Alright, so let's go back to our before unload demo. So, okay, adding a before unload listener at 2 for this global. 0, it's 112cc1000. Okay, great. And now let's close the tab. Do I ever see CC2? Found no child. Okay. When we attempt to... So free inner So we're attempting to do it. We did add it here. We failed to remove it here, even though we did do free inner objects, and that's because the tab child was not found. So the tab child might not have been cleared, or may have been cleared to. We don't see it anymore. It got destroyed. Free inner objects. So maybe it's too late. When would we destroy the tab child relationship? So where does that tab child relationship exist? If we pass a tab child get from, when you pass it a DOM window, we get at the doc shell eventually. So if we're trying to do the doc shell here, and if there's no doc shell, we return null pointer. So there must not be a doc shell, or the doc shell does not have a tab child ID anymore. Okay, so which one is it? Well, we could attach our breakpoint, attach a breakpoint and find out. Let's find out. So this is tab, what content process is this? 82862. Let's attach Xcode. Vohio, says JoeFish90. Kappa, I'm gonna say. That's what people on Twitch say, right? I'm not very cool. Okay, so we've got that done. What I'm gonna do is, I'm going over here. I am going to rerun this script. Oh, sorry, I'm still at my breakpoint. I haven't continued. I need to take out a bunch of pre-existing breakpoints. So the question was, where did I do that cool sound from? Some folks in Twitch want to know, where did that sound come from? I have this little application I wrote called Wacky Morning DJ, which I think I talk about in episode 16 or 17 of The Joy of Coding, if you can find a copy of that. So I have this little tablet. The battery pack is here. Let me just disconnect. I think I can safely do that. I have this little tablet that is networked to my computer. I wrote this little application so I can kick off little sounds.
Hey, what happened?
So I've got a little soundboard here, a little digital soundboard that I can play whenever I feel like that warrants a sound. And learning this, to me, warrants a sound. Here you go. All right. So we are attached to our breakpoint. Note that every time I do that, I'm adding more unload event listeners, and that's fine. And now what we're going to do is I want to add my breakpoint. So I'm going to pause execution. I'm going to break at tab child get from. I think I have to give it a namespace. Mozilla DOM. I think. Okay, good. And hoo boy, there's one. You know what? I might end up hitting this all over the place. You know what? Okay, I'm gonna disable this breakpoint. It's too intense, but I can add a breakpoint maybe right here. In free inner objects. Okay, so I'm going to close this tab now. Okay, we've hit our breakpoint. We're freeing inner objects. And is this the one that we care about? We are at 44400, and the one we added to was BF400. So no, we don't care about this one. Nope. What? And we never hit our breakpoint for the one that we cared about. That's terrible. I wonder if... Oh, I know what happened. We were force killed. Hang on. Force shutdown. After a couple of seconds, if the parent has told the child to go away, and it hasn't yet, if we're at a breakpoint even, it will just forcibly kill the content process. Shut down. Child process shutdown. Crash timeout. Let's see. Child process shutdown time in seconds. I'm going to make that 120 seconds, so 2 minutes. I got 2 minutes, and I'm going to do a restart. Alright, so before unload, so now we're back here again. Let's attach our breakpoint now. 8:30:66. Or attach the process, set our breakpoint. I have 2 minutes to debug. That's correct. Oh, so intense. But I haven't actually, so I don't actually have 2 minutes to debug because I haven't started closing the tab yet. But that is true. So I am, for some reason, being told to free inner objects right now. Why would that be? Whenever I render a thing. Okay, so some other unrelated stuff in the page tried to free inner objects, so I don't care about it. I don't care about that either, or that. But we added, for this global, 11B528C C00. So that's one we're going to watch out for. We're going to close this now. And that's the number we're going to look for. So our timer, that 2-minute timer, is going to start going off in a second. That number we're looking for ends in C00. Here we go. That's the one, 528C00. Okay, so the question is, where's the tab child? Where's the tab child? Do I have a tab child? I'm actually going to fast forward down to here. We're going to go into here, and then I'm going to step inside to get from. We're going to get the dock shell. Is there an outer window? There is an outer window. We're going to get the dock shell from it. Did we return a dock shell? I'm not sure. This M dock shell is null. Oh, we stepped inside, so we're returning a null dock shell. That's why. That's why. So then probably we're going to end up passing a null dock shell here, so we return. Oh, no, we have a dock shell for some reason. Weird. So we do have a dock shell. And we're going to try and static cast that to a tab child. Oh, a dock shell is now null again. What the heck? But we had a tab child. But we couldn't static cast it to the dock shell. Oh, I think I know. Okay, I think I know what's going on. Okay. Let's stop debugging. Disconnect. Detach. Okay. I think the reason it's going wrong is not because the dock shell does not exist, it's been disconnected or anything. It's because a dock shell is a bunch of nodes in a tree, and I believe a tab child is only associated with the root of that tree. And I don't believe tab child get from works its way up the whole tree. I'm pretty certain of it anyways. Let me just double check though. So if I were to do dock shell or get from and then pass it a dock shell, yeah, it's gonna try and get the tab child ID from the dock shell. Get tab child. Oh no, it does attempt to get the owner. Do get interface the owner. So it does try and go up to the top of the tree. So it might be because we've disconnected from the dock shell by the time we're destroying things. That I can believe. That it's too late. There's no way of knowing what the dock shell is at this point by the time we're freeing inner objects. So we're too late, folks. We're too late. Free inner objects is too late. So is there a better place? Aha, there's this thing called detach from dock shell. Maybe we should do it before then. Let's see what's happening. It's 202. T-blot, yeah, I do hope nothing is overriding operator bool. That would be bad. Called on inner window detached from dock shell means windows being torn down. Drop references to script context. This is probably how we're entering free inner objects. And this is where the dock shell goes away. But I wonder if detach from dock shell. This is an NS dock shell destroy. I wonder if detach from dock shell is still too late too. From here when it's called. Dock loader destroy. Yeah, the dock shell parent is item. We remove the child. We remove this dock shell from the parent's child list. That's why. Okay. That is what is up. So it's too late. It is too late to get the tab child because we've disconnected from, or at least it's too late to get the tab child via the dock shell. Is there a different way of getting the tab child? So the tab child, because I believe it still exists in memory. There are a couple of different ways of getting a tab child. But I think they all end up going the dock shell route. What about the pres shell route? It attempts to do it from the dock shell. And from the layers ID route, aha! Ah. There's a static list. So I could try the layers ID route. I can also just get all the tab children, apparently. Set tab ID. Get tab ID. Is there a way of associating? Let's see. Get all, get from, and then the layers ID. And who calls that with layers ID? I don't think we're going to be able to do that. The layers ID is something that the compositor cares about. So let me write down the problem. Why is the counter not being decremented when the subframe is destroyed? The answer, free inner objects happens too late for us to get a handle on the tab child to Yeah, too late for us to get a handle on the tab child that we need to inform. Interesting. So I might need some help. I might need some help. I'm gonna see if I can request some help. And request some help from someone who knows DOM better than I do, perhaps. Hey, I'm live hacking on the permit unload thing again. Had a question that you might be able to help me with. Mind if I... Okay, I'm just making sure he's cool with us talking live online and me broadcasting it. Just wait until he says yes or no. Okay, great. Okay, this is the chat client I'm using. This is Mr. M-Y-S-T-O-R, who I'm going to request help from. Great, thanks. So one thing I've noticed is that free inner objects in NS Global window is too late for us to inform the tab child that we're removing, that we're going away so it can decrement the before unload count. This is because by the time free inner objects comes around, the doc shell that we're associated with has been detached from its parent, and tab child get from relies on the doc shell tree structure to find the owner, and transmute that into a tab child. But now that I say that, now that I explain it out loud, just because it's been removed from the so I guess I should formulate that into a question. Is there a time earlier than free inner objects where the doc shell is still attached to the tree to do this kind of thing? Like, what was the one we were looking at here? Uh, Maybe sometime in doc shell destroy before this bit. Hmm. Alright, so while he is helping me with that, let's see if I can think of some other way. Get parent doc shell. And the part that yeah, we get the doc shell parent as item and we remove the child. That does what I think it will probably do. Actual tree item, web browser, remove child. Nope. Imagine you would need some combination of free inner items and a dock shell destroy for the times when we tear down a window while reusing the dock shell. Oh, that's a good point. I wonder, so I've been closing the tab. What happens if I browse away? Um, so free inner objects, we've added one for here. And now if I browse away, instead of closing the tab, oh, no, still no tab child there. I imagine if free inner items is called in the dock shell case. Here. Dock shell destroy probably is what he's pointing at. Right. Then he's got another place. Where we realize that the window isn't going to go into the BF cache. Wait. Hmm. Hmm. Do we not have some other example of a thing that the topmost inner window keeps track of? I have some other example of a thing that the topmost outer window keeps track of for all loaded inner windows below it, like modal state or something. Because I feel like this should be something we probably... It's caution only people in the documents are in the BF cache, which we aren't worried about here. Oh, okay. Hmm. Hurt to do. So the question from Twitch is, can I explain what I'm trying to fix? I'm trying to make tab closing faster by not doing useless messaging to a potentially hung content process. If we know that a before unload event has not been set. So we're trying to make it so that the parent process knows which tabs have windows loaded in them that have set before unload handlers. Okay. I wonder if... Like, what happens if we just, like, let's do something really dumb and move the removal of the dock shell from the parent-child's list down below the detaching from the dock shell. Let's just try that thing. Just to see if it's even possible. It might break a bunch of stuff, but let's see. Well, it's compiling, so that's a good first step. Okay. Back here, run with JS. We got our before unload event listener. Now let's browse away. Oh, hey, and we found 0 there. So we actually tried to count. That's interesting. But let's go back. But was it for the right? Found 0. We set 1 for 6,000. Found no tab child. Still didn't find a tab child. What? What? Let's try that again. I'm pretty sure I saw what I saw, but let's try that again. Now let's try closing, or let's, instead of closing, we're gonna go to my blog. No tab child. And is that because there's no doc shell? There's no way of getting from the doc shell. For the entire tabs going away case, it might be easiest to do the work in destroy window. Oh. Oh, yeah, that might be way easier. So apparently we already have some hooks where the tab child knows when one of its... Oh, well. Stuff to do with iframes being removed. If the tab child has been told to be destroyed, I guess I really don't care about the count anymore. I really only care about subframes being unloaded, which might decrement the count. In that case, you might only care about NSFrameloader destroy doc shell. What's that? Destroy doc shell. This code runs after the frame loader has been detached from the browser element. I'm confused. That seems to run in the parent. I'm really only concerned with windows within content. This frame is used for Zool browser and iframes. Ah, I see. Gotcha. I think I'd forgotten that. Okay, because that does make sense. So destroy doc shell. as frame loader destroy. Start destroy. Is there a we even get the NSI doc shell trigger called content shell removed. I see. Yes, this is starting to make a little more sense. Thanks. Content shell removed. Where does he see that? Here. Let the tree owner know that we're gone. Yes, that's what we need to do. There's a doc shell. What is M is top level content? Add tree item to tree owner. M is there not a great explanation for what that is, but I agree that this seems to be a good spot here. If we know that a content shell is being removed, a doc shell is being removed, we tell the tree owner about it. Maybe the owner can ask the inner window, hey, how many before unload events did you have? Content shell removed. It's a content tree owner, Chrome tree owner, Zool window, doc shell tree owner. Shell removed. And yeah, these three implementations are not super clear. They don't really do anything. This just tells the Zool window that we've removed. When the Zool window thinks that the content shell has been removed, it goes away. Okay. Get parent doc shell. And the tab child, so here's a question. Doc shell. What's the parent? M tab child web navigation. We create a web browser, NSI web browser, which we query interface to a web navigation, and then so I think we have this thing called an NSI web browser. Shell remove web browser listener, unbind listener. Name set name. get tree owner. Oh, we just create this thing called an as docshell tree owner. So maybe that's what's being called here in frame loader. As frame loader, whenever we destroy the doc shell, we say owner, we get the owner, the parent item, and we tell our owner that a content shell was removed. And in ns doc shell tree owner, that means that if we have a tree owner, we pass it up the train. Otherwise, we, like, eventually we'll probably just reach here and don't do anything. So I wonder here, if a content shell is removed, we might want to do the work here to get a tab child. There are a couple places where we try and get the tab child. Okay. Oh, and we have tab parent add, tab parent destroyed. Okay. Who added this stuff? This is all the old embedding stuff. Okay. Oh, okay, so let me write some of this down. It's possible that it would make more sense to notice when the the frame is going away, when so the page with some potential before unload listeners is being browsed away from in ns frame loader destroy. So maybe we'll want to do it in here. Maybe update primary tab parent. If we're a remote browser, no, we're not a remote browser. We're inside. We're in the content process. If we are owner content, what's mchild message manager? So we just start destroy and then we say destroy runnable. Then we run a bunch of different destroy steps, I think. Yeah, here's the destroy runnable. In the out of process case, tab parent will eventually call destroy complete once it receives a delete message. Here we destroy the doc shell. Here if we have a child message manager, so mchild message manager might be the way of knowing we are inside process. Describe child message manager. Tab child. It's the in process tab child global. I don't care about the in process tab child global. Oh boy, get enter manager. All right, folks, it's 2:32. I don't know if that was very interesting, but I kind of hit a roadblock there. I think I'm going to need to ask for more help at some point. And I'm probably just going to I'm just going to walk over there and talk to some people to get their opinion on where best to put the handling. Like right now we've got it working so that we notice when an event is added, we know when an event is manually removed, a before unload event is manually removed. We need to be able to handle the case where it's been added and the frame goes away, like we navigate somewhere, and so we want to decrement the count on the topmost tab child so that we don't count it anymore. And that is where we're stuck, and hopefully I'll learn more by the end of today. I will update these notes. If you are following along, there are these notes to this bug in the agenda. I think I put a link here, right there, yeah. So you can follow along as I learn more. You can follow along in here. I will flesh this out, and then hopefully I'll have more updates for you next week. Hey, that was it. That's episode 97 of The Joy of Coding. We're really getting close to episode 100. Episode 100. That's the big deal, that one. I highly recommend filling in my 100th episode survey if you haven't done that yet, so you can tell me what you think I should be working on. I also want to encourage you to help me make Firefox faster and to gather performance profiles if Firefox is being slow. Grab a copy of Nightly. Run the performance steps. Here, there's steps right here on how to get reporting a performance problem and how to submit them to me, and I will analyze them for you. So you can fill in this form and submit a profile. Do it. Do it! And I also encourage you to rate this episode. Let me know what you thought. What could I do better? What do you want to see more of? What do you want to see less of? Click on that link. It's all over the place. In fact, let me drop a link to that in the Twitch chat if you want to rate me there as well. Boom. And let me know what you thought. And that's it. Hey, we did it. We made it. It's at the end of episode 97. I'm sorry it wasn't a lot of movement, but hey, that's software development sometimes. It's a little frustrating. Sometimes it doesn't go forward very quickly, but that's life. And but we did land a patch at the very beginning, and that felt nice. Anyways, I hopefully will see you next week with episode 98. Take care. Bye-bye. Hold on a second. There. Take care. Bye-bye.
The joy of coding.
See ya.